We're joined now by Professor Samuel Bentley from LSU. Coastal Louisiana is losing land at a rate greater than anywhere else in the US. Could you tell me why that is, please?
The land loss is occurring primarily in the Mississippi River Delta. River deltas around the world build land as a result of sediment delivery from the river to the coastal ocean. They capture the sediment to build land. They can lose land as a result of processes such as coastal erosion, coastal subsidence, the sinking of the land surface, or the global rise in sea level. And in coastal Louisiana, for about the past century, the sediment load carried by the Mississippi has declined by over 50%. Local subsidence rates in some cases have accelerated, and globally the rate of sea level rise has also increased.
What new and innovative approaches are being used at the moment to tackle the global issue of subsidence?
Well, some of the techniques that are being applied now, the cutting edge types of measurements, include something called INSAR, which is interferometric synthetic aperture radar, which is a technique that's used from airplanes, from satellites, to make very precise spatial measurements of the surface of land loss. And also the use of direct measurements using high-tech instruments like fiber optic strain gauges, which it can actually measure directly the change in the elevation of the landscape with respect to a point deep in the earth.
We're in New Orleans at the moment, and there's a large amount of work that's being done around the Mississippi River Delta to gather data. I wonder if you could just tell us a little bit more about that, please.
Well, over the last several decades, the state of Louisiana has worked closely with the United States Geological Survey and with the United States Army Corps of Engineers to develop networks of permanent stations that measure environmental characteristics and also land surface elevation. There are about over 300, maybe over 350 of these stations that are electronically connected with data acquisition systems scattered throughout coastal Louisiana. And this system is referred to as CRIMS, or the Coastwide Reference Monitoring System, which has recently been renamed to something even better, SWAMP, the System-Wide Assessment and Monitoring Program.
And last question for us, Samuel, could you please tell us what people could do to help? How can people get involved with this initiative?
This is a global problem, and it's actually driving real political change in a negative sense in coastal Louisiana, to the extent that land loss over the course of decades has caused depopulation of coastal parishes because of increased hurricane flood risk. We actually lost a congressional seat in the U.S. House of Representatives in 2010 as a result of this. I call it political disenfranchisement. And the main thing that we can do is to recognize that this is a socioeconomic problem and a political problem that is far more than just regional. It's worth billions of dollars in damages and in destabilized economic networks every year, and the conditions are only going to get worse if we treat this as a local problem that's provincial in nature and don't adopt a national strategy to deal with land loss at the mouth of the nation's largest river and one of our biggest waterborne transport networks.
Thanks very much for joining us, Samuel.
Thank you very much.
That was Professor Samuel Bentley from LSU talking to us today at AGU TV.